All right. Hello, everyone. Welcome to my talk. My name is Adam Jahr. I am the founder of ViewMastery. We are the ultimate learning platform for learning the Vue.js framework. By show of hands, who either uses Vue in production, okay, or has dabbled with it? Okay, a decent amount of you. For the rest of you, don't worry, it's not a completely Vue talk. It's going to be more on the topic of web rendering with some examples in the Vue ecosystem. If you're not familiar with what we do, we are a learning platform totally devoted to mastering the ecosystem of Vue.js. So on our platform, we have a comprehensive library of 50 plus courses, whether you're just getting started with Vue. We have it's a free intro to Vue course, so you can get started for free learning the essential syntax and go deeper from there, learning about state management with Pinia, Nuxt, etc. We also have content taught by library authors like Evan Yu himself on our platform. So the topic of today's talk is actually rendering revealed, because when we are building a modern web app, we have a crucial question that we need to answer, and that is, how are we going to render that app? Is it going to be more so rendered on the server side? Are we going to instead look at rendering it on the client side? Or are we going to do some sort of hybrid approach? So in order to make that decision, we have to understand what these acronyms mean. And I don't know about you, but seeing all these, and they seem to constantly be growing, it sometimes feels like you can be drowning in this alphabet soup of acronyms. So what this talk is intended to do is to reveal what these mean, how they differ, so that we can get clear on what the best kind of rendering strategy is for our specific use case. In order to do that, we're going to take a brief history and time travel back in time to get an understanding of how we got to where we are today. So we're going to go back in time specifically to 1993. Why 1993? That is the year I got my first computer at home. I'm an elder millennial, so my dad was pretty tech savvy, and he brought us home a computer. Pretty soon after that, I was creating beautifully pixelated illustrations in Microsoft Paint, playing equally pixelated games like Ski Free. Anyone remember this game from the 90s? Okay, a couple of you. Well, for those who don't, you were skiing down a very pixelated slope, and a Yeti would attack you, and you had to outrun him. So when I wasn't skiing, I was surfing the web because we got dial-up internet, and when I was able to convince my family to get off of the phone so I could dial up and access the internet, I was surfing early pages like GeoCities pages. And without realizing it, I was engaging with the first kind of rendering mode we're going to take a look at, and that is static. Now, at their core, these static sites were composed of static HTML, as they sound. And every user who visited a static site, they would be served the same fixed HTML pages. And while they did and still do serve a purpose for simple sites, maybe a local restaurant that just needs a landing page and a menu, something like that, static page is going to serve those needs. But they're not ideal, of course, for anything that needs to have dynamic data or personalize based on who is using it and how they're using it. So as the web quickly evolved, we essentially were using that web for more things. For example, we no longer needed to go to the bookstore or the library to get a new book, like Animorphs or Goosebumps. Any more of you have that as your favorites from the early 90s? Okay, I see one of you. Okay, cool. You and me. All right, so what Amazon was in 1995, that was the introduction of an MPA, so a multi-page application. There were over 1 million books, each with their own page, hence multi-page. So these websites, they were, of course, they had multiple pages, each accessible by their own URL. So you're essentially fetching content from those URLs and navigating between those pages. That was going to require a full page refresh, and still will if you're engaging with a modern MPA. With an MPA, when you're visiting a page, that means that you're essentially requesting that page from the server. The server is going to go ahead and render that page on the fly. In the case of Amazon, it's going to take the title, description, image, etc., cook up that page, and then send it on back to the client. And because each page is rendered on the server, that means it can have its own metadata, which means it's going to be very nicely SEO friendly. Also, I mentioned that full page reload. It has its pros and cons. One of its pros is that it offers a very clear navigation experience. Your user understands if I click here, I refresh, I go to that new page. Nothing complex, nothing surprising there. It's also fairly easily scalable to build out an MPA like this. However, because every page request is going to involve a round trip to and from the server, this can lead to poor performance as well as issues with state continuity because you're refreshing and losing that state every time you navigate around the application. So with all this in mind, what might an MPA be well suited for? You might use an MPA for a large e-commerce site with a wide inventory of products on that site, or maybe a real estate or job listing site, particularly that has different entry points that users might enter in from. You might use an MPA for an administrative or a governmental site that has a lot of domains and services under one umbrella. And there's many applications for an MPA. As we move forward in time, in 2001, we saw the introduction of Wikipedia, which is a classic MPA, devoted page per topic area. And this rendering strategy was going strong for bigger sites, and it really wasn't until 2004 that we saw some really innovative alternatives proposed by Gmail with the introduction of the SPA architecture. Now, with Gmail, they showcased the potential of creating really dynamic, responsive, and interactive web apps through the use of JavaScript to handle the UI rendering and the client-side logic. And because Ajax was used for the data fetching in the background, this eliminated the need to do those full-page reloads, and it allowed the user to receive real-time updates and navigate really seamlessly around the app, and all while maintaining their state within the client. And the introduction of SPA architecture was timely because just a few years later, in 2008, we saw the introduction globally of iPhone, Android, and their respective app stores. So this catalyzed the native revolution, where users had apps that they were using that had really fluid interactions, that they had instant feedback, didn't have visible loading delays. And it really had a cohesive design language that created an expectation that users had for their digital experiences, those really nice, snappy, fluid experiences that an SPA on the web would help reflect better. So it was not a coincidence that major companies like Twitter in 2009 transitioned from an MPA to an SPA, enhancing their user experience with a more dynamic interface. So if we take a closer look at how an SPA functions, probably many of you know when we talk about single page specifically, that refers, if we're looking at Vue.js or something like React, it's the index.html file, which is the app's entry point. Everything is loaded within here. And with an SPA, because we just have that one page, we're really, as we navigate around, we're doing client-side navigation, and we're just changing the view and what components are rendered within that view. So we're able to create a more fluid, a more native, a more snappy user experience. But of course, SPAs are not perfect. They do have some downsides, because browsers have to go ahead and download the entire JavaScript bundle before rendering the components. This is going to potentially lead to damage in performance scores like your CLS, your LCP, especially if you're on a slower connection or if your user is on a less powerful device. And because everything is rendered on the client, your pages can't be crawled and indexed well. So you're going to be having poor SEO, and you won't have the ability to do those social media content previews like you would with another kind of rendering strategy. So, understanding the SVA's pros and cons. They are particularly suited for web apps with a dynamic user experience where immediate feedback is essential for your user. This would include something like a user dashboard, an analytics tool, certain kinds of social networks, and highly interactive productivity apps as well would function nicely as an SPA. And as the use cases for SPAs expanded, we eventually saw the introduction of full SPA frameworks. So in 2010, Google released Angular, and this was offering really a library that made it easier for developers to create and manage their SPAs without so much of the complexity if they were to do something like this from scratch. This was followed up by Facebook. In 2013, they released React. And pretty immediately, we saw major platforms like Instagram, Airbnb, and Netflix adopt the React library. And then a year later, which is exactly 10 years ago as of February of this year, we saw Evan You release the Vue.js framework. And this was rapidly adopted by its own major sites like Alibaba, Xiaomi, and later GitLab. And of course, as many of you know, these frameworks are massively impactful, as is now and were and will continue to be. But the increasing demand for fast-loading, SEO-optimized sites, along with a more efficient developer experience for building such sites, this all spurred the development of meta frameworks. Next.js for React, and Nuxt.js for the Vue library. These essentially sit on top of and supplement the frameworks that they sit on top of, and they're going to provide some boilerplate, some optimizations, and just make it even easier to build really robust modern applications. So we're going to take a deeper look into Nuxt rendering modes. And we're going to compare how those differ with some other modern frameworks. So with Nuxt or Next, it's possible to still create an SPA, and you would gain some of those additional benefits. But really, the common reason why developers choose it is to get those challenges that they had been facing relative to SEO and performance taken care of by leveraging its built-in support for alternative rendering strategies like SSR or server-side rendering. With SSR, taking a look at how that works, the browser is going to request a web page from the server. It's going to be built on the server, and any data is going to be fetched at that time, and then it'll be sent back to the client. And as it sends it back, it's going to include any of the necessary JavaScript as well. So when the client receives and downloads that JavaScript, that is when client-side hydration occurs. So what do I mean by hydration? That means that the event listeners are attached, Vue or React is connected to the DOM, and the page becomes fully interactive, so that button clicks, form submissions, and page transitions all are working. So in essence, hydration is what takes that server-rendered app, gives it life, and makes it a dynamic application living in your browser. The reason we call these universal apps is because it lives universally. It has a life on the server as well as a life on the client. You might also hear this referred to as isomorphic. That's the synonym for universal. And with SSR, because you can move dependencies and data fetching to the server, this allows us to achieve a faster initial page load, improved performance scores, and really an overall smaller client-side JS bundle. And crucially, because your pages can be crawled and indexed, your SEO will benefit massively accordingly. And you will also have the benefit of being able to share social media content previews like this. So where is an SSR going to shine in terms of use cases? So it's going to shine when real-time content is key. For example, a breaking news site, when a user visits a page, you can be pretty sure that that user is going to receive the latest version of that news. Or maybe a live sports site, you can ensure that the scores that someone's seeing on their page is going to be matching the action that they're seeing on their television. And for better or worse, online shopping is not just about anonymously browsing product pages anymore. It can be highly personalized, customized based on user behavior, interests, etc. And an SSR could help you achieve that kind of customization. But what if your site doesn't necessarily need to be so personalized or dynamic? With a library such as Nuxt or Next, we can achieve SSG, or static site generation. Now, as it sounds, this allows us to generate a static site, and it's going to essentially allow us to pre-build the pages. With Nuxt, we'd run the next generate command, and that's going to go ahead and create those pages. And then they can be deployed to any web server or hosting service capable of serving static assets, such as a CDN. And then you'd benefit from the global distribution and performance optimizations therein. And then at request time, your user is going to receive that pre-built page automatically sent to the browser without any need for the real-time page generation. And it's going to ensure fast load times and an improved performance. However, it is very important to note that there is a major drawback to SSG and a use case that you'd want to avoid. If you have a large site with many, many pages, then your build time is going to be very long. So imagine if you had a breaking news site and you wanted to be first with that article, but you had to wait 30 minutes, an hour, 2 hours for thousands and thousands of pages to be statically built. That's not going to work for your use case. So SSG is best suited for very static sites. Sites like a portfolio, a landing page, marketing page, documentation site, and content sites like blogs that don't need to be constantly changing and updating. So getting a feel for these different rendering modes, you might be thinking, well, I've got certain pages that would work really well as an SSG. Some might be better served as an SPA. I would love to do some sort of combination of these. Well, fortunately, in the context of Nuxt, specifically Nuxt 3, we can achieve this, and we can achieve a hybrid rendering approach with different caching rules per route in our app. One such of these hybrid-enabled rendering modes is the SWR, or Stale While Revalidate. This is not exclusive to the Nuxt ecosystem. This can be utilized as well in Next.js and other contexts. But how it works is you can kind of think of it as essentially SSG on demand. So when a user visits a page for the first time, that page is going to be built, sent back to the client, and then simultaneously it's going to store that built page in the cache. And importantly, when we're talking about SWR, there's two different ways to achieve this, and that is with and without a time to live, or a TTL. So what does that mean? So without a TTL, that means Nuxt is going to save the API response that was used for generating the first version of that page. And then on the next page visit, that cached HTML is sent. And then only the API is going to be called on those subsequent requests. And if a change is detected during such a request, the server then returns the stale response, and it's going to generate a new version of that page in the background, which will then be served on that next request. Alternatively, with a TTL or time to live set, we are essentially programming a timer that's going to count down and reset the cache at that interval. So when the time is up, the page is regenerated and then cached in the background. Similar to SWR, we also have ISR, or incremental static generation or regeneration, depending on the context. And this is going to function very similarly in terms of its rendering and caching strategy to SWR. The main difference is that if you are using this, that you can add the response to the CDN cache. So if you look at it with a no TTL set, that means the content is going to persist until the next deploy inside of the CDN. But when we look at this behavior specifically, it's important to know that it's really only available to us on the platforms that support it, and that's going to be Netlify and Vercel currently. That might expand over time, but that's where you can do ISR like this right now. All right, and looking at ISR with a TTL set, it's going to be similar like we saw before. We're setting that duration, counting down and regenerating when it expires, and replacing the cache accordingly. And as I alluded to, ISR is possible with Next.js. The major difference between how Next.js does it and Nuxt.js does it is with Next, the pages are all going to be generated at build time first, whereas with Nuxt, they're going to be built at request time and then cached and regenerated according to your TTL configuration. So now that we understand how caching modes work, we can look at a simple setup where we might implement route rule-based rendering for an app. So let's say we have a home page that we want to be SSG, whereas our admin page could function more like an SPA, and our blog, we can incrementally regenerate that page. So in Nuxt, we'd head into our Nuxt config file, and we can set up route rules to achieve this, where here, pre-render true, that is telling us we want that page to be pre-rendered and function like a statically generated page. SSR false essentially says don't do SSR for this route. Instead, it's going to function client-side like an SPA. And then here, ISR 3600, we're essentially saying incrementally, statically regenerate this at the increment of every hour on the hour. And this is from the Nuxt docs, just so if you want to take this hybrid approach, you would have to avoid building all of your pages, all of your site as an SSG with the Nuxt generate command. You instead would either do it all as an SSG or take that hybrid rendering approach. So we delved a bit deeply into Nuxt.js. How does this compare to alternative frameworks? So if we look at Next.js, we pretty much have these same rendering modes available to us. The implementation details might differ subtly. And when we look at it as such here, we're really talking about the Next.js pages router. With Next.js 13, we got the app router. And while essentially these rendering modes are still achievable, things are conceptually simplified into server and client components. So if we add the use client at the top of a component file, that's going to turn it into a client only or SPA file, whereas by default, everything else is going to be a server component. And the actual rendering strategy is going to be chosen automatically by the Next.js meta framework, depending on what it sees in that file, like get server-side props for real-time data, or get static props indicating that they should be pre-built pages. In Next, you can leverage client components for the parts of your UI that need to be interactive, rely on state, hooks, APIs, browser APIs, and React class components, and then everything else, like you see here, can just by default be those server components. And a cool thing with using React suspense component, this is going to enable streaming. So you're essentially sending your pages via like in chunks progressively from the server. So essentially able to allow your page to be interactive before everything is ready for it to be fully interactive. So this component-based approach for rendering different components in different ways, it is not just isolated to the Next.js framework. there is a similar strategy in a newer framework that came out in 2021 called Astro. I'm calling this a Neo framework. It's basically a framework, but why it's Neo to me is that it can be composed with multiple components from the major JavaScript libraries. So you can kind of create it's almost like an umbrella under which your React, your Vue, etc. components can live together and form an app together with those rendering strategy fine-tune adjustments possible. Now Astro, it has helped popularize the concept of the islands architecture, where in Astro, only the island sections are going to be the interactive pieces of your page. And as I mentioned, you can compose an Astro app with components like Vue, React, Svelte, Solid, and it allows really fine-tuned control over how those components are hydrated, how and when, with these client directives. But Astro is not the only framework that's using this island approach, because within Nuxt we have an experimental component called Nuxt Island. So it's going to give us similar functionality, but this is actually inverted. So the islands are going to be the non-interactive parts of your page, or the server components, which I actually think conceptually as a naming convention makes a little more sense. Maybe I'm just being too literal, but the hydration is hydrated, so it's wet, it's the water, it's the sea. Non-hydrated, it's dry, it's sandy, it's land, so it's the islands. All right, so zooming way, way, way out, what are the kind of big takeaways for where web rendering is, and where is it heading in the direction that we're seeing based off of all these slides? Well, we're looking at fine-tuned hydration control, either on a component level or on a route level. And we're looking at shipping less JavaScript. So now that we're inundated with all this rendering knowledge, how do you go about choosing the one that is best for you? You might have an idea based off of what you've seen so far, but this chart here is a decent way of getting closer to your answer. So you might want to ask yourself a series of questions. The first would be, is SEO important to you? If it is, you probably don't want an SPA. You can ask yourself, how often does my app update? If it's minute by minute, you wouldn't want an SSG, SWR, or ISR. Hourly wouldn't work so great as an SSG. Ask yourself, how do you want to host your app? If you want it exclusively static, then you don't want an SSR, SWR, or ISR. And then finally, is the first load performance of your app important? If it is, then you probably want to avoid SPA and SSR. I'll give you all a second to take a photo of this. All right, so for example, for my use case with ViewMastery, we're a content site. We do care quite a bit about SEO. We update more so on a weekly basis. We prefer to host statically, and we do care about first load. So for us, arguably, we should be an SSG. We could also take a hybrid rendering approach if we want to make our content pages SSG while our users' learning dashboard is maybe an SPA, etc. All right, with that said, I invite you to, if you are curious about ViewMastery, about learning Vue, like I said, we have the Intro to Vue 3 course, totally free, available on our website. But if you want to become a subscriber, you can join today at a 50% discount. That is live on the site for everyone now. Just head to viewmastery.com, and you can access that discount. And if you haven't seen us way over by Duck Stage 4, we do have a booth with cheat sheets. We have one on Pinia. That is essentially a state management tool, the redux of the Vue ecosystem. There's a Nuxt cheat sheet as well as Vue Router. So it has all the essential syntax for these different aspects of the framework. Also, I wanted to let you know that I personally would like to connect. If you have any issues or needs where you need content production and strategy, maybe you have a product that is technical in nature, you need help getting users or would-be users to understand the value props of it, how it works, how to use it to its max potential, you can reach out to me for anything like explainer videos, tutorials, marketing videos, etc. So I appreciate your time and attention. Hope you enjoy the rest of the conference. And if you see me at the booth, I'd love to get to know you a little bit better. Thank you.